So hi, very good afternoon to everyone. Hope you are greetings of the day. Hope you all are having a great day, and it is indeed a pleasure for Saptarshi, me, and my colleague Hanuman to present our paper on optimizing and improving ABB's global forecast using the forecasting and analytics engine. We truly appreciate all of your time and presence, and we hope we add value to your time and the whole conference. I will just share my screen. Okay. Can you see my screen? Is it visible?
Yes, sir, it's shared.
Okay, thank you.
We can see the slides here.
Okay. So, okay. Okay, so what we are doing over here basically is we are improving ABB's forecast. So I'll just start with what was our idea behind forecasting. So we found out that we are losing a lot of business, in a lot of revenue and a lot of cash flow in improper forecasting, because forecasting is an important aspect of all the businesses, and if we do not forecast in the proper way, then it can be a huge loss for the businesses, because forecasting drives the entire revenue and it is somehow linked to the entire planning and the entire supply chain. We thought that why not do something in forecasting which will be sustainable, which will be beneficial for the business, and which will even add value for the final customer. So we created because earlier we knew that people used to do forecast on the Excel, or basically it is a spreadsheet driven forecasting which doesn't have much logic except the usual time series. So what we did was we created a global AI based forecasting tool which uses an ensemble of machine learning algorithms to give you an optimum forecast. The optimum forecast can be at the plant level, it can be at the part level, or you can zoom it up or down to the business level or to any level you want. So our approach to forecasting was we tried to incorporate all the trends of seasonality and demand and supply fluctuations in the for maintaining the desired service level. We started off with univariate time series forecasting. We also did multivariate time series forecasting. Then we advanced our model to multivariate multi-layer forecasting using external variables. We did the conditional demand analysis and parameter analysis, and this is how we use the machine learning and neural networks to try to solve and forecast for the complex business and supply chain problems. And we also understood what was causing unprecedented demands and what is the predicting of the technological changeover points. Okay, so in univariate time series forecasting, if you can see the screen, right side is a snapshot of our tool developed. The interface of the tool has been developed in Power BI, and the backend calculations and the backend logics have been worked on in Python. And we have developed these models. So for univariate time series forecasting, we used Profit, we used Holt Winters, we used Autosys. I'm not going to go into the depth of these models because over here I have just written how these models work, which is a basic know-how. I will not go into much detail about how these models work, rather how we use these models to forecast for the business. So in multivariate time series forecasting, we use long short-term memory, which is a type of neural network model to forecast for the future values. And then we used XGBoost, which is a powerful tree-based and versatile model, which is having significant applications in many streams. We tried to apply this particular model into time series forecasting. In the right side, you can see a correlation. I'll come into this. So what we thought was of technologically forecasting for the variables. We did a conditional demand analysis to find out what are the main key causes, like what are the external derivative market factors like crude oil prices, US net oil imports, and things like that. We also evaluated the global macroeconomic parameters like US industrial production index, GDP per capita, consumer confidence index, to name a few. And then lastly, we also evaluated the key customer share prices. All of this we tried fitting into the main model to get a correlation on how they are affecting the main demand. So the backside correlation, you can see it is the overall matrix, and over here we have refined out to 2 or 3 important parameters which we thought have a good correlation. Then we also feel that analyzing the substitution growth curves are important, and the market usually follows an S trend shaped curve in which you have to particularly find out the change points over here, like in this case of the black and white and the color television inception. You can see that the technological changeover point started at 1945, and this is the point after which the demand exploded. So you have to find out the areas where the technological boom will come. This is a snapshot of the Nasdaq 100 companies top listed. You can see how the inception boom, which started into the computers industry, eventually began. So if we understand these unprecedented demands and unprecedented changeover points, then we can forecast accurately is what we have tried to show in this paper and what we have done in our analysis. We basically need to understand what is causing the unprecedented demand, whether it is a technological changeover point or whether it is some other thing, and then we have to go ahead and fit the model. So we did an extensive testing of the model. We fitted the underlying data set with the projections from a different model, which is known as LSTM, the recurrent neural network model. And then the key derivatives, the key projections which came out from that were fitted into the regressor to find out the final forecast. We got a mean absolute percentage error of 42, which we found out to be good, reasonably good, the accuracy, overall accuracy of the plant, considering many of the parts and many of the parts had scattered demand and they were not basically having a good correlation. So 42, we evaluated all the neural networks compared to the statistical forecasting models. We found out that XGBoost is standing out as the winner. We also had close to 42 is 47, which is LSTM, and so on. So basically, yeah, we felt good that we were able to forecast using the external derivatives and see what is influencing the market, and how to take it forward. So basically this process has not been completed, but we are in a way, because we feel that we will go much further in the forecasting front, and we will be able to solve the complex business problems or the technological changeover points which might be predicted for any company or any industry, to overlook, to get the paradigm shifts which are happening in the market, and to best fit our companies and our business model with that of the market. So thank you. Any questions you can ask? I didn't go into much depth because I know that we have a 10-minute window. So I would not have been able to complete the main agenda if I would have anything else. Hanuman, if you want to add anything, you can. Or if you have, we have any questions from the audience, we can answer them.
Thank you very.
Yeah, well explained, and yeah, we open for the questions if any.
Yeah, thank you very much. So far, I can also see that this is a very interesting project. You have continued and you have done it. It's a very interesting things. Have you checked about the, the acceptance among the business people? Because so far, as you said initially, that normally we are using this Excel thing. So, and the second most important thing to accept in the business community or the business people, we see one very famous term, ease of use.
Well,
so how much it's easy to understand and use it for the business people to focus their upcoming things by using this model?
I may answer on this, and thank you for asking for that question. So of course, like we work for ABB, and it is kind of the traditional company we have here, and people are not like always open for the new tools and techniques. So our interest or our intention is that we work with the business. We ask them that in which area or which tools they are comfortable, If it is the spreadsheet or Excel, we work according to that. And slowly we move to the more robust technology and more robust tools and techniques. So that is how we are working currently within ABB, that we work in the spreadsheet, we make them understand and slowly move to the further level of understanding more.
And second, my question is how different it is from the SPSS?
Over to you, Saptarshi.
I mean, using SPSS also you can do. It is basically the model building. We have built the models using Python, and you can build them. You can build a robust model using. So the main underlying concept behind this is that there are many fronts to develop your tool. If you want to forecast or if you want to do the approach using any particular method, you can do it. We chose this approach, and we are good with the results.
There is no doubt. It's a very interesting and very good. Thank you very much, sir, for your very good work done. It's still in a process, right? It's still ongoing.
Yeah, so it's an ongoing process, as because I said that forecasting is such a thing which you can never get 100% accurate, and we are moving forward to increase the accuracy. So in that way, we are working to make the model better, to understand the correlations of the market parameters and of our underlying derivatives and assets over here better. And yeah, I will say that we are not finished here.
Well, I would just add that we developed a complete tools, and now we have challenge of incorporating those oil crude price, market trend, seasonality. Seasonality of course is there, but like the current recent pandemic, so how that could be streamlined or could be used more efficiently in the tools. So that is something we are working currently.
Yeah, thank you for adding that, Hanuman. Yeah, just to complete that question, this is the screenshot. If you can see my screen on the right side, topmost picture, that is the screenshot of the tool which we have currently developed. It is a full-fledged tool which can forecast for any business line, any plant, country, or division. You have all the necessity. You can see the key parameters like what is the on-hand inventory quantity, proposed inventory value, and things like reduction potential and what should be the optimum forecast over here. It is a very user friendly and key tool for the businesses.
Thank you very much, sir. Thank you. Very interesting. Great work.
Great work, sir. Thanks a lot.
Thank you very much. Yeah.
Okay. Any other questions we have, or is it?
I assume we don't have a question from the audience. Yeah, because no one has asked any question.
Okay, thank you.
Thank you, sir.
I mean, we are open if anyone wants to have any questions, or if anyone wants any idea regarding anything, they can reach out to me or Hanuman, and you have our email IDs over here, hanuman.swami@in. And this one, you can take a screenshot, or you can reach out to us over LinkedIn if you have any good ideas or any projects regarding this. We will be happy to collaborate or work together, because we are very much interested in this new front, and we would love sustainable and technologically focused individuals to join us. Thank you.
Thank you. Thank you very much, sir.
Thank you.